Alright. I'm live on 2 platforms for no reason whatsoever. And holy shit, that is loud. Okay, wonderful. Fortunately, no one watches my streams, so this is a good way to test it. Well, if you are watching this stream, there, trying to get the audio to work, and it appears to be working, which is fantastic. Now, here's my question. How do I get the chat? Oh god, that's not what I wanted. Didn't really think ahead on this one. I guess I could just move that off the screen. Because see, I'm streaming on YouTube and Twitch for the first time. And I'm just trying to figure out how to get my laptop organized so I don't look like a crazy person any more than usual. Cool. Well, that's working. Wait. Oh, fuck me. Literally, did that stop playing because it went off the screen? No. Okay. Well, cool. Anyway, I'm Scott, and today, if I was ready at all for this, which apparently I'm not, I'm going to be putting together this thing. What is this thing? I don't really know what to call it. It's going to be a test box because I have a bunch of multi-voltage power supplies, like the kind that go from 3 volts up to 12 volts or 24 volts. Basically, I bought a bunch of them, and I couldn't decide like which one was best based on Amazon reviews, so I kind of figured I'd, test it for myself. Anyway, this box, which is going to be in this project box, will simply take power in from the mains, have an LED to indicate the power is on, a circuit breaker to make sure it doesn't break. That's out of focus. Master power switch. Those have a really shitty voltage and amperage indicator in the form of these very cheap things, which I think look cool but aren't actually that useful because they're not very accurate at all. And then a bunch of banana clip test points. Banana plug test points for live, ground, and neutral. And then also live, ground, neutral on the other side. The idea being that if I want to tap on the live side, I can put a multimeter across these two banana sockets, disconnect the pass-through switch, and then monitor the current very accurately. And there'll be a couple of LEDs to monitor whether the output is on or off. That's the idea. It's not really like necessary. There's much simpler ways to do this. I just kind of fancied making an elaborate project, like a needlessly elaborate project. And so, anyway, this is the box that is going into. The start of it comes from this power cord. I got it in pink because it looks cool, and it will look different from most of the other cords that might be on my bench at the time when I'm testing something. Just so I don't cut through the wrong wire by accident, which I have been known to do. In fact, I did it kind of recently. It was very embarrassing. See, there's that little notch gouged out of this wire cutter at the bottom of these wire strippers? Like, that should be a flat surface for cutting wire. I cut through a live power cord with those, and it gave me quite a start, but didn't actually do anything of consequence, which was lucky. Well, other than pop the breaker on my surge protector, but, that's kind of what they're there for. Well, that's not actually what they're there for, cutting through live wires on top of your table, but anyway, so standard 15 amp rated, 14 gauge, grounded power cable. I'm going to hack it up. Basically, I'm going to reuse the plug and the socket. Initially, I was going to put a GFCI plug in place of this plug for safety purposes. Because there's going to be banana plugs here which are connected directly to the mains, and should I accidentally touch one of them or have a patch cable going out of one of these like hanging loose on the bench and I touched it, in theory this would help protect me. I mean, it's not like you should rely on one of these for your life, but it's, good to have. Problem is, I realize that I might eventually want to do a some kind of test, like a test of a GFI, in which case I might want leakage current going to ground, in which case it would trip this and not the thing I was trying to test, or whatever. So the change of plans is that this is going to go on a little patch cable, and this way be optional. I can put it in line or not. The second stupid thing is that I went out of my way to get this cord because it has a lighted socket on it. Or at least I think it did. Let me plug it in and just make sure that's even true. Oh yeah, it's tremendously dim, but you can see it right there. Now, I realize if I'm trying to get an accurate current measurement of whatever device is plugged into this, even though that neon indicator will barely draw any current whatsoever, it's still something. So I realized I'm not going to actually use this plug end on the whole project. Instead, this plug end will be paired with the GFI, making a little tiny extension cord, which then this can plug into, and I'll replace this with a different socket. So, point being, I can now hack this cable to bits, although not with this shitty cutter probably. I'm going to leave a little extra slack there. That's probably good. That's probably about 2 feet. And I'll set that aside because that I will do much later. Sorry, my microphone's all fucked up. Okay. And then as far as the length of this goes, I want a fairly lengthy amount of cord so I can plug this in far away from my bench if I need to. And I'm just kind of, I don't know. Actually, you know what? I'll just do the standard hand measurement thing. So it's about 6 feet. So yeah, I think 6 feet is probably fair. 6-foot power cord's fairly standard length. And chop. See, this way I know I'm cutting through the right cord because it's pink. But when I'm actually using it, I won't be cutting through it, so, you know, it'll be the opposite thing. Now, one thing I left out is that I'm going to be using this box, which I bought because it has a nice, cool start-stop switch, as like a remote disconnect for this. Now, I fucked up because this is not latching. It's basically just 2 buttons, and they're momentary, so it's one or the other. And since this is not being hooked up with anything electronic, that won't do me any good because I don't have to hold down a button while this is in use. So then I bought this pretty cool giant paddle switch. It's actually got a latching start and stop. And then, of course, in an emergency, if like something was on fire or I shorted something out or was smoking, I could hit that stop button quite dramatically and it would be very awesome and it would shut off power to the whole device. The problem is the back of this is very deep and it won't fit in a standard junction box, or well, I was going to put this in an outdoor rated enclosure just because those are nice and robust and plastic. But yeah, it didn't fit, so I kind of put the kibosh on that. I happen to have one of these switches, kind of a cheap eBay type deal, although I might have got this from Amazon. Simple on-off. It's got normally open and normally closed contacts. So I was going to use this as the main power selector, or power switch. And then just to fill in the other hole, because these standard size holes, I have this, which is an alarm indicator. Basically, it has a little buzzer inside as well as a couple of flashing LEDs. Now, I don't want the buzzer to buzz whenever this is on. That would be annoying as fuck. So what I'm going to do is probably just chop out the buzzer and just use the flashing LEDs because, well, for no other reason than I think it would look kind of cool. The other thing is, for extra safety, I'm going to put a circuit breaker in the side of this box, and basically power is going to feed in one side of the box, out the other, and then go to the meat and potatoes of the whole thing. Again, completely unnecessary. I just thought it'd be kind of fun to have. And I saw this box and thought it was cool, and then went down a rabbit hole, and now I have to commit to doing something with it. So this power, so the power, So the power is going to come in through here, go through this box, through a, let's say about a 3-foot length of cable, into this box, and then through a very short length of maybe like 6 or 8 inches of cable to a socket. So, yeah, it looks like about 3 feet. Oh my god, these cutters suck. That's my fault, though. So, first things first, let me get this and the GFI out of the way, because I'm not going to be dealing with that right now. And open up this box. Yeah, help if I put that towards the camera, not away from it, huh? And now this box isn't what I would call, like, robust. You know, it looks like an industrial piece of equipment, like an industrial on-off switch that you might have hanging from, like, a crane or something. Well, not crane, because it's 2 buttons, but you know what I mean. With, like, a lead going to a control box, a controller somewhere. But this is not robust at all. It's very cheap plastic. I almost don't trust it for, like, line voltage type stuff, but I'm not going to be bashing this around theoretically, so I'm not too worried about that. I don't know. So, very simple. On the bottom, it's got nothing except this cable gland, and in the top, it's got the 2 buttons on the front, and then these use kind of a standard release, which if I have a screwdriver, I can show this to you. It's got these little, I don't know, notches there, and if you push the screwdriver in there and kind of bend it out and up, the whole thing just pulls out. This is a clip that holds that on. Oop. There. Well enough. So these are the actual buttons. Like, I don't know that anyone cares, but let me just take this apart a little further, because these are very modular. Like, you could actually have 2 different switches on either side of this, because this mounted like this. You could put a second one on this side, and this could activate 2 different switches at the same time by pushing down on this, and then this one's normally closed, so pressing that button will open those 2. The other one, I think, yeah, is normally open. So you could actually combine these into one unit and have one normally open and one normally closed circuit on the same button, which is kind of cool. I like the flexibility. Not necessary for this project, of course. And then these just unscrew off the back, as most of these types of things do. It's got a little... Oh, this box makes a very feeble attempt to be waterproof or water resistant by having a gasket there, but the gasket doesn't even fill up the space, and then this very thin ridge that goes in. I don't know. It's not what I would call robust. But I'm going to keep this little washer with that anyway, just because even if, like, not to keep out water, it does help keep out dust and debris, but more importantly, it sort of helps this to sit and not rotate. You know, then it helps to snug it up against the end of the case, or the top of the case. So, yeah, so I'm going to use this dealie. Now this has a release mechanism. If you push this white thing in, it allows this to pull apart. And then, quite simply, let's see, this is going to be the top of it, so I'm going to put the switch on the bottom, and I want it facing up when it's on. So, there we go. That should be fine. Alright, and then, oh, one thing, yeah, I did check the clearance, I believe. And I checked to make sure, because this only goes in one way. Sort of at an angle, but that's fine. Oh yeah, good. A little bit of clearance at the bottom. Not a lot, but more than enough. Because basically this doesn't need to be any more than that clearance on the bottom. It does kind of encroach on the edge here, but I think this should still fit. Yeah. Oh. Hope I didn't take the washer off of there. I'm going to mount this with the buzzer still connected. and sort of test it out that way. And then, like I said, I'm just going to chop out the buzzer. I'm not going to do anything fancy other than take a pair of snips and just kind of go nuts on it. See, but that looks cool. That looks very industrial. That's not perfectly... whatever. Yeah, right. On off, that looks pretty cool. This will be flashing when it's on. This will be off camera though when I'm using it, so it's not distracting. And I'm sure those LEDs probably aren't terribly bright, but I guess we'll see. I'm just kind of being bold by just wiring this up without actually testing that, but whatever. And I think this also has normally closed and normally open, and you can see, should have showed it in a better light, but you can see on the side there all the contacts, so you can tell which is normally open, which is normally closed. This one is normally open, and this side, I believe, therefore, yep, is normally closed. Very versatile. Now, one thing that actually may be a problem here, because this cable is fairly thick, I'm just realizing the cable gland is sort of, when these are put together, right next to the edge of this switch. So that might actually foobar this whole plan, at least using that switch. Ah, shit. Well, if I rotate it, actually, it's not going to look the way... Oy. I'm kind of doing this, well, live. That's why it's a live stream, so I really haven't planned every single aspect of this out completely. So that slots in like that. So if I turn it like that, hopefully that'll give me the clearance I need. That's going to put the switch at a weird angle, which is not very desirable. Like, that'll be on, that'll be off, but I guess that's fine, because then I can put an on-off label here, like, you know, off, on, and then it'll make sense. Okay, I'm not that angry about this. It's still going to be tight, though, between the cable gland and the body of the switch, but I think it'll work. Yeah, it'll work. As long as I don't have the jacket of the cable protruding into here, as long as the conductors are just coming right out, this should work fine. The other thing I want to mount on the inside is this circuit breaker. And that, I might be shit out of luck. Now, I have a plan of putting a circuit breaker on the other box. I was going to actually put 2 circuit breakers in series. Completely unnecessary, just like overkill safety crap. So maybe I'll omit the breaker on this intermediate box, because there's just not going to really be any clearance for it. Because these both protrude almost to the bottom of this case. So I can't, like, put the circuit breaker under those. Although maybe under this one, but that would be extremely tight. I mean, if... No, that's just looks dangerous. Fuck. Well, that's incredibly disappointing. I mean, I could just omit the flasher. You know what, screw it. I'll just omit the breaker from this box. This box is sort of just for fun anyway. So, whatever. Now, is this cable gland that came with it going to lock down tightly onto this cable? Oh, actually it will. Yeah, that's actually pretty good. Okay. Didn't know if this would be sized correctly, but it is. And then for the other side of it, I have this package of cable glands that's very similar. Basically the same design, just in black. And I want to find one that is the right size to capture this cable adequately. And this looks roughly the same as that one, and so let's see if it will capture this cable. I'm not even tightening it all the way, but it should. Oh yeah, that's actually good. Nice. Oop. Okay, now this one won't have a problem fitting because there's plenty of clearance between the bottom of this and the side of the case. This just will require... It's got a knockout. I don't know if I'm going to have to drill that or not. Let me just try bashing it with a screwdriver a couple of times. Nope, that's just going to crack the case if I do that more. I'm just going to drill it out. Which I will pre-drill. Let me go back out here with a standard drill bit, and then I'll move to a step bit to actually ream it out the full way. I just got a new Makita drill recently. I've never actually owned or used any Makita products, but I keep seeing other YouTubers use them. I have DeWalt and Milwaukee drills. I actually like DeWalt. Well, I liked DeWalt best, but now I'm really starting to dig this Makita. Milwaukee's not bad. It's just that, you know, a lot of it is just feel, like the way it feels in your hand, and I just prefer DeWalt and now Makita. Plus, they use Makita on the International Space Station. I don't know if that actually recommends the tool, or they just were the winning contractor on the bid, or was it? I don't know what the deal is, but it is commendable, I suppose. So now I need a step bit that will hit the proper size. You know what, let me just use the big ass bit. It's the most universal. You know what I'm actually going to do, though, is get another drill. Yeah, let me get another drill, because I'm going to have to drill a lot more pilot holes for this. So I'm going to just keep one bit in each drill, just to make my life that much easier going forward. So, I'll be right back. Wonderful. Oh, fuck, I got a cough. Yeah, I figured I'd spare you that. Sorry about the background noise as usual. I don't know if you've seen any of my recent videos or streams, but I kind of try to explain that every time, that the background noise is all the servers behind me. And so, yeah, not too much I can do about it right now. Ultimately, I do want to build a partition between this part of the room that I'm in right now and behind me, to contain the noise and the heat and all that other shit. So I'm gonna kind of just, well, just because I'm kind of a maverick, I'm not even gonna bother trying to determine what size this should be in advance. I'm just gonna ream this out to about the size of the knockout, and then, oh, that's not nearly enough. And just then go up from there to get the cable gland to fit through. Man, this bit is dull. I've actually cut metal with it. Oh yeah, that's perfect. So, shit, I mean, it'll work fine for plastic, but wow. Just, oh my, this is going poorly. Alright, anywho. Oh, let me get the plastic shavings out of here. I mean, the advantage of having plastic shavings everywhere is that they're non-conductive, so if they get into stuff, they're not going to short anything out. Metal shavings are a lot more concerning in that regard, for obvious reasons. Alright. This nut does not have any sort of bias to it. In other words, it's not like knurled on one side to get more grip. Now this plastic, I think I'm good with hand tightening, because it's kind of chewy plastic, and I don't necessarily trust it to really go much tighter than that without breaking that nut or stripping it or something. Anyway, that should be fine. Okay. So, what am I doing? Okay. Let me strip this before I put it through. Now, you know what? I'll strip it after I put it through, because I can kind of just, like, take a bunch through and strip it this way. you know, feeding it is easier before you strip it. Not that it really matters. Now, as far as stripping this kind of cable goes, I'm sure there are many ways to do it. You can't just use ordinary, like, wire strippers, because even if you had ones that were wide enough, the jacket is molded around the conductors. So in order to actually cut through all of the jacket, you would actually need to cut through at least the insulation on the conductors, which is not good. So speaking of cutting through insulation on conductors, the way no, is that dull? Well, let's see. The way I do it is, and I need a decent amount of, is I cut through the jacket very carefully. Oh wow, this jacket is very soft. And then, but hopefully don't cut through it all the way, and then I sort of peel it back along the cut line. And if all goes well, there will be no incision on the insulation of the actual conductors, which in this case there is not, which is brilliant. And the only one I don't mind if I get a little incision on the insulation is the ground, because it's not really that bad if you have a ground wire sort of loose in your device. In fact, it could be desirable, I guess. And then to get the rest of it off, I just sort of nip around the edge. If it's a particularly stubborn or like tightly molded cable, I'll just go around it with a knife. But this is safer, because if you don't do it spastically, like I'm doing, you don't risk nicking the conductors or the insulation thereof. Yeah, nice enough. Should be long enough. And then I got too much shit on my bench here. I call it a bench. It's really just a table, and it's really, embarrassingly, just an IKEA table. But it's served me well for quite a long time. It's like that kind of, it's hollow on the inside. It has a hexagonal mesh of cardboard between two thin veneers of wood or wood-like material. And you'd think it would be flimsy, but it's actually quite strong. I've had a lot of like heavy equipment on this table at one time or another, and it's held up really well. And this table is easily 15 years old. Not that anyone wants any Scott lore, but this actually came from my old office. I mean, it wasn't like my desk, but it was someone's desk at that office. And we got actual desks eventually, and my boss gave me this table. And I like the color of it, because like this wood or fake wood color, it like contrasts nicely with pretty much everything. Like if you have a black table, you wouldn't be able to see anything black against it, because there'd be no contrast between the object and the table itself. So wood's sort of a good color that, you know, electronics aren't really wood clad nowadays. I guess for vintage stuff it might be confusing, but anyway, let me strip these conductors and then figure out what I'm going to do from there. Actually, let me I don't even know where these are going right now, to be honest. And I don't know how I'm going to splice this together. Like, I don't know if I'm just going to solder splices or use wire nuts. Maybe slightly more temporary and reconfigurable, oh, I forgot what those connectors are called. The kind with the orange levers that flip down and lock the cables in place, or lock the conductors in place. So, yeah, get that right to the edge so there's not really any jacket sticking through. And lock that down. It is pushing it through as it's locking it down. How rude. Yep, kind of got out of shot there. Anyway, got that locked in place. Get this sort of positioned nicely and lock that in place. And let's see how good these cheap cable glands do. Give the non-scientific pull test. I mean, I don't want to go too hard because Eventually I could just rip the jacket on this cable, but yeah, those are definitely in there securely. Hooray. Okay, now the buzzer / light device needs live and neutral. So I can't just splice the neutrals together. I have to take a tap off of it to go to there. And then the live obviously has to be tapped for that and then go through the switch. Well, first go through the switch, then, yes. You get the idea. So the power is incoming on this side, so obviously, I guess the switch should be on that side. Kind of makes more sense. No, the switch should be on that side. So that's fine. These terminals are not exactly what I would call robust. I wouldn't trust it to have two wires going into that terminal, so I think I'm going to have to splice the live conductor before it goes in there in order to run it to the buzzer. Wago terminals, that's what they're called. And I think I'm going to use them. Hang on, I'll be right back. I got to go get those. Wago terminals wouldn't necessarily be my first choice for this kind of project, because if it's a device that can be moved around, I don't have anything to secure the Wago terminals to the inside of the box. So they kind of just be rattling around inside there, which I guess a wire nut would be, but these are a little heavier, so they could sort of knock things out of whack. But that being said, it's not like I'm taking this device on job sites and where it's going to be kicked and bashed and have all sorts of things happen to it. How many? 3? Yeah, that's fine. I got a variety. And so for me, I guess in this context, it's more important that it be reconfigurable. So these are the Wago connectors. I mean, in fairness to Wago, these are Wago style connectors. These are knockoffs from eBay. Which, you know, if you want to talk electrical safety, maybe not the wisest thing to do. I would not use these knockoffs in a permanent installation in my walls, because I think that's just asking for trouble. But for this application, I think it's fine. So the very first thing I want to do is go through the switch, but then I need a little jumper wire to get from the switch to the Wago terminal that will split off to the buzzer dealie. This can be very short. How short is it? I want to be able to get both halves of this part easily though, so you know what? Make it slightly longer than I otherwise feel I would. That's too long. There. Like I said, I didn't really plan the details of this out too much. I just made... This isn't really a diagram. This is going to be printed on transparency stickers, and so it's going to actually be stuck to the top of it. All these giant circles you're not going to see, that's where the cutouts are going to be. And so it's just going to be the lines representing the interconnections between those components. It's not going to be the best looking thing in the world, I can promise you that, but hey, I'm more of a function over form type of guy anyway, so whatever. Let's see how... Ooh, I stripped this... Oh no, that's good. That was a good length of stripping. And it does retain pretty well. I mean, I think Big Clive actually looked at these, and I'm assuming I got them from the same knockoff source that he did, and he seemed to think they were pretty reasonable quality. So, like I said, I'll go with that. Again, gotta cut that shorter. I would absolutely not use these in my walls or in my ceilings or any other type of permanent installation. The whole point of this entire setup, these boxes, is that I'm going to be actively monitoring them while they're in use. You know, like I'm going to be testing stuff. So they're not going to run unattended. I don't really have to worry about that. Yeah, it's fine. So, yeah, so again, this is the output side. So now this will come from the switch. And then this side will go back out to the buzzer arrangement. And for the buzzer, I'm going to actually use even thinner gauge wire, because obviously the current consumption of this is going to be almost nothing. Although, you know what, I don't have the 3 amp breaker in here. That's another thing I should mention. The breakers that I was going to put in here, and that I will put in here, are 3 amp, because I'm going to use some fairly light gauge wiring for some parts of this, And it's not only that, it's that I don't want this thing ever subjected to a high load. This is really just for testing power supplies and testing relatively low current things. So 3 amps should be more than enough for whatever I'm going to use this for in the future. So I don't want to ever claim this whole thing is rated at 15 amps. I'd rather just claim it's rated at 3 amps and then feel better about myself in the morning. Or whatever time of day I need to feel something about myself. I really do wish I could get this breaker in here. I guess if I bend those... No, it still won't fit. I was going to say, if I bend the contacts up, how much would that buy me? It would almost buy me enough space, but not quite. Fuck. Well, the walls of this top piece are thicker than the walls of the bottom piece. Yeah, but I can't mount it there because the cable gland is down there. Shit. You might be able to get away with it on the side if I mount it really far down. Fuck it, I'm going to give it a shot. Okay, so the switch is going to be there. So I don't want it next to the switch. I want it down here next to the buzzer, and I want it as low in the case as I can possibly mount it. Yeah. You know what? I'll give it a shot. Worst case, it doesn't work. I'll have a hole in my thing, which is not really desirable. So do I want to do this? Or do I want to just see if I can... Like, these contacts are closer to the bottom than they are to the top. So if I mount this really low in the box, actually it might... You know what? I'm glad I use Wago terminals now, because now I can disconnect that and insert the circuit breaker instead. Oh, actually, it wouldn't be on that side, it would be on this side anyway. Look at me talking bullshit. So is that going to have clearance if I put... Because that's to clear this inset area of the case. So if I put it right next to that inset area, is it going to clear the switch? That's the question. It looks like it will just barely. It's going to have to be done in fairly tight tolerances, which is not really my milieu, especially when using hand tools. Yeah, this is going to be done in an incredibly approximate way. Okay, that marks the edge of that. So if I put that down there, assuming this thing is relatively parallel to the whole thing. I am going to drill a hole right there. And I'm going to use a black marker on a black case, which seems stupid, but in a certain light it should be visible. So there, and roughly there. Okay, now for some very approximate drilling. Theoretically, that should do the trick. Fortunately, I can still fudge it a little bit. But let's see here. Oh! Yeah, that might actually be just about perfect. Okay. Sweet. Use the overkill bit of the century. This isn't the smallest one, and this isn't going to ream it out too far. No. But the second step is going to be too much of a step. So, you know, let me change this for something a little less drastic. This is the kind of fun shit you only see on Livestream. Oh yeah, that should be fine. Well, or rather, this is the kind of shit that you, the theoretical person watching this, that's not actually watching it. But whatever. No, let me zoom down a little more. There we go. Well, not a little more. I got two options, either that or this. That's not big enough yet, is it? Nope. Better safe than sorry. think the next step, though, might be it. So I don't want to go farther than that. No, I do want to go farther than that. Aha! Will it fit and line up properly? Oh yeah, it's very bottomed out. Okay, there it is. And I actually had a little leeway on the side here, but that should work nicely. Yeah. Now will... I mean, also routing this wiring around the switch while I put this back together is going to be a huge pain in the ass. I can guarantee that. Like, this is going to have to stick up in there. This is generally going to be a huge faff, but just eyeballing, it looks like I got more than enough room there for all this to sort of be crushed in there. Now, what I do want is some nice spade connector for that, and I happen to have... What the fuck camera did I just go to? I happen to have a whole bunch of crap on here. I got some heat shrink tubing, got these connectors, which I'm going to show you right now. Yeah. Oh my fucking god. That camera. These are like knockoff 3M terminals, whatever those crimp terminals are called. Hopefully they are the same size as the terminals on the circuit breaker. These are all the same size terminals though, right? What the why are those spades wider than the... Oh, there we go. Okay, it's just a very tight fit. Nice. Okay. I'm in. Now, blue is good for 14 gauge, which I'm out of sight there. Oh my god. Yeah. Oh god. Yeah, I mean, I like that it's a nice tight fit, so that's cool. I don't have ones that are fully covered. Oh shit, I think I do. These are completely unsafe, actually, for this application. I'm talking bullshit here. These are the ones I want. It's a styrofoam in it. Yeah, these are the insulated type. This is what I want for a tight fit in a case where things might roll up against it. Cool. Okay, so the power inlet, therefore, is going to get one of these connectors, and I gotta cut this wire shorter. Of course, I just have an explosion of now little copper strands everywhere, which is great. This is actually, yeah, this is full copper. This isn't copper clad aluminum. Good. It's supposed to be a good quality extension cord. I don't like to cheap out on extension cords. I usually get 12 gauge. I don't even usually get 14 gauge because why mess around? But in this case, like I said, I'm going to breaker this at 3 amps, so I am less concerned. And then, you still seated? Yeah. Now hopefully, oh yeah, that's nice and tight. Cool. So that will go in one side of the breaker. And see, now it's all insulated quite nicely. So nothing will hit it and short out, hopefully. Okay, so now I need a jumper to go from the breaker to the switch. And this should be pretty short. Actually, I should make these very short, because otherwise I'm not going to be able to cram all this wiring back in here. Oh, we pulled the whole strand out. That's disappointing. You know what? I was going to be lazy and say I'll just use it, because this whole thing's going to have an overcurrent protection at 3 amps. So I don't even need all those strands, but you know what? Someone's gonna bitch. Be like, oh no, you shouldn't let that slide, so I won't let it slide. By the way, this little patch wire I'm using is also 14 gauge. It actually looks to me to be a little shy of 14 gauge, but that's what it was sold as, and that's what it says in the spool, so for very short runs in panel wiring, I think it's probably fine for even 15 amps or more. That's a nice connection. There we go. Okay. So now I can tuck the breaker down there. And again, I could just theoretically solder. You know, if you're trying to do a project like this, you could just solder to those spades, but you know, I like to keep the stuff reconfigurable for the future. This is the little, this says press to reset on it, as well it should. I kind of wish it gave the amperage rating of the breaker, but that's okay, I can label it myself. I mean, I'm sure they just use one nut for everything. Now, the only thing that's weird about this is now this is sort of sticking past the bottom of the case by the tiniest amount, which I don't really care about. I mean, if you're being completely anal retentive, which you should be with electrical stuff, that's actually bad, because if this slides across the table or something, that could work loose, and then this component gets loose, and that's always a bad thing. But like I said, this is going to be well supervised by me and only used by me, so I'm not too concerned about that. I could just grind off the bottom here to make it flush and put some feet on here anyway to raise that up, so not bothered too much. Okay. So now this jumper goes to the switch, and obviously I want to go to the normally open. Not that it matters. I mean, technically, actually, I want this to be off, so whatever's off right now is the one I want. Doesn't really matter. I mean, it's a switch. It doesn't really matter which one's normally open and normally closed, because it just would define what position does what. So what is off right now? You're not really going to be able to see this, I'm sorry. Yeah, so this top one, the one closest to the flasher dealie, is the one I want to use. I mean, the good news is you can't fuck it up, because worst case you wire it the wrong way and it's just this is off and this is on instead. It's not like it's the end of the world, as long as you label it correctly in the end. Use my wee little screwdriver here. Yeah, this is going to be a bitch to get these two halves put together without pinching or otherwise, you know, fucking up any of this wiring. That should go to, if this mounted like this, actually, let me wire to that side so it doesn't have to cross the whole switch body. Okay, maybe I should have made this slightly longer, because this is kind of a pain in the ass. Oh my god. And I'm kind of out of shot. Oh my god, I'm almost out of shot. Okay, this is not like a standard Phillips screw. So maybe I should use a flat blade driver. Ah, there we go. So I can't really exert too much force on it, but well enough. Definitely well enough. Okay, so then we want to come out of the other side of the switch to this whole arrangement. Am I in shot? I'm barely in shot. This has to open up a little more. Something makes me think that like 14 gauge wire was not really on their mind when they invented these switches or manufactured them. In fact, I don't know. These are definitely rated for line voltage. I'm just not sure what their ampacity rating is. Does it say? Probably, you know, that's like the kind of thing you should check, to be honest. No? Oh, 10 amp. Doesn't give a... Oh, 380 volts. Oh, wow. 380 volts at 10 amps. So, breaking this at 3 amps is actually wise. The only thing giving me pause here is the ground. I might actually solder the ground, because that's something that you do not want to have accidentally disconnected or pull out of one of these Wago terminals. Ground is for safety. Ground is to be worshipped. Or the earth wire, as other people call it. Alright, yeah, so also, like I said, for the buzzer, I use this very thin gauge wire. I don't even know what gauge it is offhand. And if you're not in the United States, probably like, gauge, what the fuck? And that's because we use, of course, American wire gauge, because why would we use an international standard, like square millimeters or something? That would just be silly. That's sarcasm if you couldn't tell. Anyway. So this is, oh god, I'm totally out of shot. This is post switch. Actually, you know what, it's going to be easier to tie it to this first, because this is going to get a little fiddly to get in here. I haven't actually used one of these buzzers before, but I've used the other type of indicators that I also have on the bench, and the screw terminals on here are very finicky. And they really don't take thick gauge wire, like you have to use very thin wire like I'm doing now. Which, you know, is not great if, for example, you have these on a circuit that's, let's say, has overcurrent protection to 15 amps, and there's like a short or some kind of significant fault inside this, and using very thin wire, this wire is going to act like a fuse potentially, and get very hot. Maybe some plasma would be involved, I don't know. And generally a bad day. Which again, why I wouldn't wire anything this way that I was going to leave unattended. Just want to make that very clear. I just kind of hope that captured the wire itself and not the insulation, but I guess we'll find out. Do I want to solder the ground? I guess I should. That would be like the more robust and thorough way to do it. Before I do that, though, let's get some... I mean, I'm not entirely averse to leaving bare ground wiring in there, but I'm still gonna get some heat shrink tubing and just heat shrink over the connection. And I actually can keep it fairly tight, although I want to, no, you know what, I want to leave it kind of longish so I can bend it around the outside of these, the switch and the indicator. So let's say if I cut about there and I cut this one down to there. And now when I do splice together, I want it to be under all this stuff. Oh my god, I'm so sorry, I keep going out of shot, wow. Oh my god, there we go. I'm not doing anything fancy here. I am just going to twist these together. First I'm going to put the heat shrink tubing on, which, glad I realized that before I soldered it. If you've never made that mistake before, you are some kind of mythical god type creature. I don't know anyone who hasn't forgot to put like a cable gland or some other type of sleeve or whatnot on a cable before either soldering two cables together or putting a connector on the end. It's I think like the most common mistake when wiring stuff. I don't know. This is not necessarily the best kind of splice because let me cough. Hang on. I feel, you know, the reason I keep muting it when I cough is because this microphone is so close to my mouth that if I cough directly into it, it would blow out your eardrums if you have the audio set to where you can hear me speak properly. So that's just courtesy as far as I'm concerned. Anyway, the thing I don't like about this kind of splice is I'm just going to solder this and then flatten it against the cable and then pull this sleeve over it and then shrink it on there. I wouldn't do that with any kind of current carrying conductor because if you have any kind of like little strand of copper that's poking through or whatnot, especially with this sort of asymmetric arrangement, as the heat shrink tubing shrinks over it, you could have something pierce through it. With a grounding conductor, I don't care quite as much, or at all. The only thing that's kind of bad about having to solder this is that I gotta get my soldering station out, because I wasn't going to solder anything in this project, but then as I'm doing this before you, I realized that certainly the grounding wire should be highly contiguous through this entire thing. Yeah, this is not the slickest way of doing this, but yeah, there. Everything one could want for soldering. Well, everything one could need for soldering. I mean, good luck doing it without a soldering iron. I guess you could use a blowtorch and just like hope for the best. Okay, now of course we all have to watch that heat up. It's like watching paint dry live on the internet. Again, I still don't think anyone's watching this live, so whoop-de-doo. I'm not going to break this off. Okay, that's gonna take a while to get up to heat, to temperature. So what else can I do in the meantime? I can hook the neutral up to the indicator. Let me get this out of my way so I don't burn myself. So here's where we're at. Now I'm going to use yellow to represent neutral, which in the United States, well, according to building code, that's invalid. Neutral should always be white, or potentially, I think in some situations it can be gray, but yellow would indicate a live conductor. However, in this entire project, actually from this box on out and the other box, I'm going to be using blue to indicate live and yellow to indicate neutral. Why? Well, because on this box I'm using for testing power supplies, like plug-in type power supplies, wall wart style. I'm going to be creating another box for the other end of the power supply, which will be DC low voltage. DC low voltage traditionally uses red and black as positive and negative. So you can see where the problem is here. If in the United States and Canada, possibly Mexico, it's a North American thing. Live is indicated traditionally, or for the most part, in homes by either black or red, although most any other color other than white or green or gray would be a live conductor. What the fuck was I going to say? Oh, right. So if on the line voltage side I use black for the live conductor, that would also be black for the negative on the low voltage side. And so while I have these boxes and like various jumper cables with banana plugs, it makes it all too easy to plug the wrong cable into the wrong hole and create some kind of great disaster. So because all my DC low voltage stuff indicates red with positive or positive with red and negative with black, I don't want to end up like backfeeding this device into one of my expensive benchtop power supplies, for example, which would just cause a huge, fire or whatever. I don't even know what would happen, but it wouldn't be good. So I'm going to break with convention, and because I have no other like banana clip, why do I keep saying banana clip? It's alligator clip and banana plug. I have no line voltage banana plugs otherwise, and so why not use different colors for those, even though they don't match North American building standard colors. So for this project, for the most part, except where otherwise used, for example in this fucking box, but from here on out it's going to be yellow for neutral and blue for live, except for the actual conductors that are in this pre-made cable. Yeah. So that is my plan. think the soldering iron's up. Yeah, soldering iron is at the temperature. What do you know? Let's let me finish up with the grounding conductor. Ew, this looks like utter shit. Just do some of that. Not that any of this is, I mean, it's not like I'm doing some fine soldering work here with some expensive electronic components. I mean, now you're going to say, oh, Scott, you're touching the solder to the soldering iron. That's bad. I'm just putting a little bit there to bridge, to create like a thermal bridge between the iron and the wire. And then once the wire is heated up, I'm going to apply the solder to the copper conductors and really soak that in there. That should be more than enough. And actually that speaks well of this cable because, oh, I actually shrunk my heat shrink tubing slightly, but it should be fine. I should still be able to get it over that. It speaks well of this cable because that insulation didn't really melt, which, even though it's extremely hot. So, turn the soldering iron off, deployed it just for that. Actually, might have melted this one back a little bit. Well, regardless, it's not really spec to take that kind of temperature. Now, you notice I didn't get the solder all the way up to the top. That's just because I was going to trim it down. There we go. And then, actually, you know what? Let me bend it the other way because I have... No, I'm not going to be able to bend it because it's firmly soldered in place. Wonderful. The solder wicked up through the thing into... There we go. Okay, not quite the way I wanted it to be. Actually, you know what? Fuck it. Let me bend it the other way. Oh my god. There we go. Yeah, see, this has every chance of like piercing through the heat shrink tubing. And if this was a current carrying conductor, I'd be kind of scared about that. Nope, it shrunk the end of the tubing, but just the very end, so I'm just going to cut off the very end so I can get it over that hump. There we go. It's already trying to poke through the heat shrink. Come on. There we go. Yeah, and that'll lay nicely down at the bottom. You know what? That tubing is not going anywhere. Yeah, I think I'm gonna leave it like that. I'm not even gonna shrink it because it can't move right or left, both because of that splice and because the way the wire is bent. It's not laziness. It's not like I'm too lazy to get my heat gun and like I don't want to blow extremely hot air into this very flimsy plastic case or in the vicinity of this very flimsy plastic case. No, no, no. It's because I think that's the way it should be. Heh. Oh, shortcuts. Is there nothing you can't do? Alright, where is that yellow piece of wire that I was holding while I was talking about why it's yellow? Now I kind of want to keep this wiring organized so that it doesn't end up being extra hard to stick back in this case. So let's go... Oh, here's another 3-position Wago terminal. And that goes in there. This is probably stripped far too long. Actually, how deep is the Wago terminal? Let's see. Wago terminal. It's not like I guess it does terminate. Is the proper name for this a terminal even, or like a splice? Yeah, it's could definitely lose a bit of length there. There we go. Nice. And then did not loosen that yet. It's always tricky to keep things in shot. Because like you're sort of wrapped up in actually doing something, trying to get the best possible view for yourself. And that is almost never the best possible view for the camera, because the camera is above me there and my eyes are over here. So whenever you see someone like working on something like this live or even recorded on YouTube, for God's sakes, give them a break. I mean, this is I don't want to say it's harder than it looks. It's not like it's hard, it's just there's a lot to pay attention to. You got to pay attention to the project, and then also to all the streaming crap, and also to making sure that it's in shot. By streaming crap, I mean like the technology side of it, and paying attention to chat and whatever. Now, fortunately, I don't have the problem with chat right now because, well, there's no one here, but you know what I mean. So this needs to be oriented this way. So you can see the problem here. I gotta cram all this shit into this box without weirdly crushing any of these conductors or doing anything stupid like that. This is already on the wrong side. See, okay, I'm now glad I used Wago connectors, terminals, whatever the fuck, because it would really help me out if I could get this around there. I don't know how many cycles these are good for as far as being open and then closed and open and then closed. Like, I can't, like, they're not really meant for, I mean, the actual Wago connectors, I think, are meant for permanent use. Like, for example, in a wall or in a ceiling by a light fixture. In fact, they're sold with light fixtures a lot to make it easier for the homeowner to wire them up. And, so I don't think they're not meant for like numerous duty cycles. Like I think, for example, in the U.S. we use wire nuts for making all of our connections of that. So, well, not all actually. We have other sorts of connectors, but wire nuts are the like traditional standard connector for use in building wiring. And I think an electrician could undoubtedly correct me on this, but I think after you use a wire nut, you're not allowed to reuse it. Because there's a spring inside the wire nut, and I think as that gets distorted and unsprung, if you try to use a wire nut again, it might not grip the cable quite as well and could lead to a loose connection. So anyway, I did manage to get this together, and without, I think without pinching any of the cables or any of the wiring. So it seems like it went together quite pleasantly. So, hooray. I was actually hoping to get farther than this, but like, it seems like these kind of projects, it always, especially when you have a distinct plan, and you're just kind of thump-ing along as you go, it always takes longer than you think it will. Now, I do want to plug this in and test it, but obviously, there's nothing quite on the end here. So, what I'm going to do is strip this just a little bit. Actually, I know I might as well strip it a lot, because it's what I need for later. Again, with great care and alarm. Now, if you hold the blade at an angle to the wire, you're more likely to cut through more of the jacket rather than the conductors, but you can also slice nicely and neatly through. See, if I open it up, now you can see I barely nicked the paper. Actually, I nicked the ground wire ever so slightly, but again, I'm not concerned about the continuity of the insulation. I mean, I guess it is technically the continuity of the insulation. That's just like a weird way of phrasing it. The integrity of the insulation, the grounding conductor Oh my god, just break. I really made a hash of that. But I did not slice through either of the current carrying conductors. So, very good. I mean, honestly, slicing through the jacket of a cable like that without hitting the conductors just takes practice. Like, I mean, initially, like, when I was a kid, I tried all sorts of ways of stripping these type of cables. Like, I'd come in with, you know, a pair of cable snips or strippers and just sort of, like, go around it and sort of gradually increase pressure until I cut through just deep enough, but then because the cable's molded, didn't cut all the way through the jackets, and you can kind of struggle and sort of bend it and get... Anyway, over the years, I found the best way of doing it is just to slice up the end and hope you don't actually slice through the conductors. Oh, actually, I had to slice farther down than I thought. And once you get it worked loose a little, I mean, you can just go in here and just do a little choppy with your snips, which, you know, may or may not be to your preference. The only thing about this, doing it this way, I mean, with the snips at the end here, is that it does not create, like, the neatest end. See, like, it's a little rough there. That does not matter in the slightest. That's purely aesthetics, because cable gland will be holding it here, and so it doesn't really matter what happened here. I guess you don't want it to be too messy, but you can see I nicked the, actually this is sloppier than usual, but I did nick the grounding wire in a couple of different places. But, like, not even to the copper, it's just a small nick. If it was the current carrying conductors, I would do it again. But again, like, I'm not worried if a little bit of copper does show through on the grounding conductor. Anywho, so point being, let me test out this box. I need electrical tape. I always have electrical tape everywhere, and yet there's no electrical tape here. That's my favorite kind of tape, by the way. I know a lot of people say, oh, it's duct tape. Duct tape's the best tape in the world. Duct tape's the most useful thing in the world. I hate duct tape. It sucks. Duct tape is much less useful than zip ties. It's a much shittier tape than electrical tape. And I'm not even just talking for electrical purposes. Like, obviously you wouldn't want to use duct tape for electrical connections, but I find electrical tape useful for many situations around the house. For example, a lot of places you could use a zip tie, for example, to attach something to something. Electrical tape is great for that, because it's stretchy, it's elastic. And if you use the colored tape, it uses clear adhesive that's a lot less gummy than the black tape, so it doesn't leave residue unless you leave it in place for quite a long time. But even then, the residue is pretty easy to clean up. So anyway, very unsafely, I'm just covering those two with electrical tape. And I'm going to plug this box in and hope it doesn't blow anything up. It did not blow anything up. It's now plugged in. This, I don't know how loud this is going to be. Oh, it's very quiet. I mean, it's not quiet, but I thought it was going to be, like, horribly obnoxious. I mean, obviously it's obnoxious. I don't want that making that noise constantly while I have this box on unplugged. So now I'm going to do something potentially that's going to ruin this whole thing and just try to snip the beeper out of there, or buzzer. I called it a buzzer before because I thought it was going to go meh, 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 you know, but it's more of a beep. Now this circuit board is actually only held on there by the leads of two resistors that go to the base of the unit. Construction is very similar to this. You're not going to be able to see it from here, but basically the only thing connecting this top part to the contacts on the bottom are two big fat resistors that are probably 2-watt resistors, for a total of 4 watts, because they're in series. No, if they're in parallel, it would be 4 watts. No, so, but anyway, this is I'm talking shit. Anyway, this is not going to draw much current regardless, so that's why they can get away with using just resistors. But that's the only thing that holds this board in the front on, is just the fact that it's sort of pulled down by those two, by being soldered onto those resistors. And again, I might regret this. But I have more of these beeper thingies. Okay, there is the membrane, or whatever it's called. And just remove that. And now this thing will not make a noise, but it actually should still be electrically, oh my god, electrically continuous. Okay, now let me plug that in. So now, hopefully, if all goes well, it should just flash. I don't know if that buzzer is wired in series or parallel or what. So, hey, that is exactly what I wanted to have happen. No noise, just some blinking lights to remind me that this very unsafe device is turned on. And the breaker I'm not going to test. I mean, I could, I guess, you know, overload it or short out these connectors, but I'm not going to do that, because that could very well ruin the breaker in the process, and then I would think it worked and didn't, and it's fairly an insignificant test for that reason. That's the other reason I wanted to put 2 circuit breakers in this project in series, is just because I got them off Amazon. They're actually, I mean, I don't know if they're like a hugely reputable brand. It's not like I've heard of them before, but they weren't the cheapest ones around. They're M&R? They're rated for 125 to 250 volt AC or 32 volts DC and 3 amps. I figure 2 is better than 1. Whatever. I'm an overkill kind of guy in some ways. So, yay, this box is complete. And I made a huge mess. But yeah, cool. I like it. Okay, now the next step is, of course, to work up this box. Now, it is currently 2:19 in the morning where I am, and I do have work tomorrow, so I'm definitely not finishing this project in one shot, or even possibly 2 shots. But for now I will prevail. This project box was an eBay special. It doesn't feel like super high quality plastic, but it is notable that these screws go into oh my god, what is the word? Inset nuts. I'll show you. You'll know what I mean when you see it. Rather than just chewing into the plastic, they actually screw into nuts. Oh, Jesus Christ, what are those called? That are molded into the plastic. So that's cool. So I think the first step for this is going to be to drill holes in it. That is what this is for. This is not necessarily the final look of this, but it will locate all the components nicely. And what I did is I put a piece of Scotch tape across this, drew a line right down the center, because this isn't cut perfectly square, so if I tried to square this up to the box itself, it would be, the diagram would be crooked to the box. But this green line down the middle, as long as I line it up with those two, the very edge that I can see of that line, this should be nicely parallel to that line and be centered perfectly. Where is my tape? Let me see what I'm doing from a greater distance, I suppose. And so, fuck, now I knocked it out of position, of course. So what I'm going to do is just get that as perfectly lined up as possible. Perfectly as possible is, I think, a contradiction, but whatever. Get it as well lined up as possible. As close to perfect as possible. There we go. Nice. And now I'm going to drill right through this. This is on cardstock, by the way. It's not just standard paper. The reason for that is if you use just regular printer paper like this, if you're drilling, like, let's say that hole right there in the middle, and the drill chews into the paper, it could end up crumpling the paper up and twisting it and then knocking everything out of alignment. Cardstock, or even a very thin piece of cardboard, I think is better for this sort of purpose. And like I said, I'm just going to drill pilot holes through this. I'm not going to use the step bit. And so also it doesn't matter what size holes I drill right now. I don't have to worry about the size of the component. I just have to worry about getting the drill nicely centered. This is going to be a better shot, I think. Let me do this. Now, oh, for fuck's sake. Sorry, I'm just unlocking this camera so I can just bend it down a little bit. Because, here's the thing, I'm streaming this live, yes, but ultimately I'm going to edit this together and make a proper video. Maybe with like narration and stuff over it. Where is the plane of focus? So, that's why I'm kind of like setting this up as I go, because... So, yeah, it's not bad. So really the most in focus about here-ish. Okay. Which is exactly where I'm drilling right now. And I'm completely covering that with my other hand. And I just really want to try to do my best to center this on the diagram. Basically, just to explain what this is, each one of these circles is slightly smaller than each component, so that the edges of the circle, even when they're printed on the final transparency, that'll all be cut out for the component to go through, so you won't see that at all. And the tiny dot is centered on it. Basically what I did is I drew a circle with an extremely thick border, so I know that inner circle is perfectly centered, because this is actually just one circle tool drawing thing. That's a good explanation. And again, I am completely blocking you from seeing this. It's kind of depressing live streaming to absolutely no one, but it's also just kind of cathartic to just be doing this for, oh god, for two purposes, I suppose. Like, one is to actually make the device, and then the other is to make the video. So it's like killing two birds with one stone. It takes a lot more effort than the one bird. Wow, didn't mean to throttle that up quite as much. Yeehaw. This bit is actually getting pretty hot from chewing through this plastic. Like, I'm kind of resting it on my pinky there, just to get it perfectly, well, as perfectly as possible, you know, by eye. Alright, and there is all the pilot holes drilled. That camera really dim. This sucks. I'm not gonna fuck with it though right now. It is what it is. So yeah, I think I got all of them. Yep, I did. So now I can take this cardboard off. And the reason I drew this center line on Scotch tape, which I did leave folded up, there we go, is that the box doesn't have any markings on it when I do that. And then as far as keying it, you know what I'm gonna do, I'm just going to mark the side here in. Actually, that's where the cable gromet's going to go. I'm just going to put it on the corner here. Oh, actually, that's dumb. Yeah, let me label the bottom of the box when the lid can go in either way. Uh-huh. Brilliant. I mean, it's pretty obvious the pattern of holes is different, but, you know, when glancing at it really quickly, I don't want to end up getting them backwards and then drilling a... knocking stuff over. I don't want to end up drilling a giant hole here and then a smaller hole here and then having that all fucked up. So, anyway. So this is the input side. No. There you go. And by the way, the project box itself, I mean, providing it's reasonably deep, is great for drilling on top of because A, it'll catch any detritus that falls through, and B, this way you don't have to put down like a piece of plywood or something sacrificial to drill into, or like try to suspend it above something else. I don't know. I like drilling through project boxes. They solve their own problem. Speaking of which, so using this handy as a template, just to make sure I'm putting the right size hole in the right place. Go back to this camera. Now this first hole I'm going to do in the upper, there it is, in the upper left hand corner is going to be for a very small indicator LED that's just going to indicate power is coming into this box. Like, there's going to be a main power switch that turns this box on and off. However, this is going to indicate that power is coming in from this box and is going to come before that switch. So as long as this is on, that'll be lighting up. And that the indicator I'm using is in this pile of crap somewhere. Okay, well, I'll get another one out of this bag. It looks like this. Doesn't really fit with any kind of style of this device. It's very like retro. It sort of looks like a 1950s indicator. I think it's just an LED with a resistor in there, and it is rated 110 volts AC. So this way I don't have to add my own resistors or do anything fancy with it. Just basically shove it through the top of the case. This I'm going to have to solder to. I'll solder a couple of leads to it, and then bada bing, bada boom, I have an indicator. So anyway, this first hole up here is going to be very small, and again, I don't know exactly how big it needs to be. Maybe bigger than that. Nope. Perfect. Actually, it barely moves around in there. Wow. Okay. It's an excellent size hole. By the way, I love step bits because if you're drilling through plastic, project boxes, this sort of thing, buy stepped drill bits. Look how smooth that hole is. And that's from these old ass bits that I've used a million times and are probably all worn to shit. I've actually cut through steel boxes with these, which they're probably not meant to do, but yeah. It makes a really nice hole with no burrs. Sometimes you get some burrs on the inside, but you really don't care if you're mounting a through-hole component like this. Like, you can see the other drill left burrs all over the place, which doesn't matter because these are all getting reamed out, but, you know, that's just a very nice fit and a very clean fit. So, anyway, just my 2 cents. Now this will be the breaker again. That's probably about this is probably 1 step larger than that hole. No, definitely bigger than that. And that last step should do the trick. Now it seems like there's no margin for error, like if you go 1 step too big then the hole's too big, but fortunately for the most part, you have some margin to work with. Like this scutcheon is far larger than the actual hole, so if I did make the hole a little too big, it'd be fine, but this is a good size right there. Brilliant. Okay, if I could actually get this to screw back on, that would be great so I don't lose it. Now for the master power switch, in fact, for a lot of switches, I'm using these nice panel mount switches. You'll see you'll notice a trend here. Whenever possible, I like to use round components that mount through holes rather than square components that I need to cut. Because cutting a project box, especially a perfect, like, neat square, much more difficult than drilling a hole in it. So whenever possible, I go for the hole over the square, rectangle, or whatever the fuck. Now, I don't even think this drill bit's not even going to be big enough, I don't think, for this switch. So, let me switch back to the big one. And, one thing I will say about step bits is they make a decent amount of mess because every single step creates a little piece of plastic like that. And usually they end up separating from each other, so if you're doing a lot of holes like this, you end up with a lot of those little plastic thingies. This is dull. I really need to get a new set of these. And that's what I get for using it on that's what I get for using it on steel, especially heavy steel that's used in electrical boxes. Let's see where we're at on that. One more step should do the trick. Yeah, man, this bit is pretty shot, actually. There we go. I mean, it still does the trick, but... Oh no, this has a key to make sure it doesn't rotate, which is good. It's got a tiny little keyway right there, which you... I don't even know if you can see that, to be honest. Let me just see. See, it's got that little bump right there. That should go into a corresponding bump to make sure the switch can't rotate in place, which is actually a good thing. I'm not terribly bothered, though, I'll tell you that. So I'm just going to brutally hack that off, and now I can insert this however the hell I want. Which is going to ultimately be like that. Now I don't want to press it through just yet, because I want to wait till I drill all the holes, but that should work just nicely. Okay, so next I've got these larger indicators. Well, here's the one that measures amperage, that's why it has this extra lead on the bottom. This connects to a toroidal coil, like so, and this obviously goes around the live for the current carrying conductor, and then therefore it can measure the current. It also takes live and neutral in to power the device itself. But I'm really here for sizing it, not to talk about it, and I am actually going to use this volts one for sizing just because it doesn't have that extra little tail coming off of it. And the threads actually don't go down that far, so I'm going to take this off for test fitting. Okay. This is... Actually, is this the biggest of the hole? Yeah, this is the biggest of the holes by far. It's that one step, like one particular step is just extremely weak. And not enough. That step should be big enough. I don't think. Oh yeah. Nice. Yeah. Just ream it out a little from the bottom. It's just this bit's dull, so it wasn't quite chewing through. I don't want to go. I don't want to put too much pressure on it, because as soon as you start putting too much pressure on it, you hit one extra step and it pops through, and then you can be screwed depending on the size of the component you're putting in. And then it's the same size hole up here. Yeah, see, once it gets that step, it just wants to spin freely. Uh-huh. Okay. Nope. Blocking your view again. Sorry about that. Boom. Okay. Just got a little bit of a burr on the bottom. Yeah, that's the other thing. If you get a little burr on the bottom, you can just remove it by going in from the other side usually. And it cleans up pretty nice. Not perfectly, but pretty nice. No, that was just static electricity keeping that on there. Anywho, so next we got the banana posts, which are all of these yellow circles. Not all of the banana posts are going to be yellow. I have a variety of colors here, and they're going to be one of those colors where appropriate. So again, just for test fitting, I think I'm going to have to go with the smaller steps, stepped a bit. And let's see, that should be not too aggressive. Now the thing is, this has a very small flange, so if the hole for this is even slightly too large, it is going to fall right through. So you know what, actually, let me be ultra conservative and go with an even thinner bit. Actually, will this one max out at the size of this? No. Max on this is still going to be too big. It'd be cool if I had one that maxed out exactly the right size. No. Alright, well, then I could just shove it right through. I don't have to worry about it. But just to be ultra conservative, I'm going to use this one with the greatest number of steps, or not greatest number of steps, but finest steps, finest stepping, I guess. And I know I can go most of the way. Now see, this one I have barely used, so it's very sharp still. Oh. Being very conservative on this. Oh, this might actually be able to bottom out. Or is it the second to last one? It's the second to last one. Okay. Can't see where I am because of all that crap. Yeah, and also these steps are very shallow, so it's very easy to go too far, so I'm just going to get the rest of it with the other side. There we go, but again, a very lovely hole. Excellent fit. Yep, just need to get it from the other side because it's just a little too tight. Because it didn't get quite... There we go. Brilliant. And then while I'm doing this, I'm actually going to attend to the other 4 banana sockets. Other 3 banana sockets. Correction. Very nice. Get that in focus better. It's very easy to get overconfident at the end and be like, oh yeah, I'll catch it before it hits that last one. but that's called hubris, actually, not confidence. So I'm being super careful not to go overdoing it on the last one or two, which I have been known to do. See? Perfect. I definitely did a little too much exuberance on that last one, but it fits just about perfectly. Now, fuck. I forgot to drill 2 pilot holes, but you know what? Yeah, I am going to do it. I am going to do it. That was dumb. Alright, well, totally missed those wee little purple circles. You know what? Put that there. And then let me actually get the flimsy ass paper that I was talking about before. Just trying to figure out the best way to line this up to make sure it is just right. Yes, that's what I'll do. I'll just get all these holes centered on the bottom, and then I should know that therefore it's lined up. I mean, look, it's not like I'm trying to win some kind of design award for this box. It's just supposed to be functional. Obviously would not win any design awards were such awards to exist for such things. I just want it to at least look not like an ape made it. And one thing I think I did realize when I was sort of sizing all this, the banana socket's going to go right there, and the LED indicator is going to go right next to it. It's going to be another one of these, and they're kind of butting up against each other like a little too much. So my plan was to just drill this hole a little farther to the side. It's not going to interfere with the bottom here, is it, though? I should be able to get away with it. Should. Let me see if I can find my other drill. Let me see how close I am with the pilot hole. And I'm going to come a little farther out. Oh yes, that's just a little too close to the edge of the case. To this inset area. I mean, I could just ream right through that because that's really just for water sealing, for water tightness. Like there's a O-ring type gasket that goes in there, which is covered in plastic shavings now. But I in no way intend this to be water resistant or watertight or waterproof, so I can omit that gasket entirely. And so it doesn't really matter if I chew right through all this plastic here. So screw it. I am just going to put that right there. And if the step bit chews through all that plastic, then so be it. And I'm similarly going to offset this one just by eye about the same amount. So it should wind up in exactly the same place, which it did not. Oh, you know why? I think this whole thing might be just offset a bit to the top of the bottom, like as far as I drew it. So I'm not too worried about that. So that one actually won't. No, that's fine. You know what? That is more than fine as far as I'm concerned. So I still have this very thin bit in there. Let me just cut a hole for this LED. One more should do the trick. Is that? I don't know if that is bottoming out on a little ledge that's in there, or if, no, that's bottoming out on the hole. Okay. There we go. Nice. Possibly a little on the loose side, but as long as the hole is completely covered. Yeah. Oh, what? I'm definitely going to have to chew out all this plastic in the corner here, because otherwise how the hell am I going to get this nut on there? Yeah, so all that plastic's got to go. Now this drilling through it is not going to work because the drill is just going to go rah, 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 rah. So I'm just going to use my trusty snips and just chew through the plastic like that. Again, this looks like a fucking horrible idea. Because it's ruining the box, but again, the only purpose of this extra little inset or indent of plastic, in something of plastic, the only purpose it serves is to hold that gasket to keep this thing watertight, which I'm not particularly concerned about. So the only thing I'm doing is I'm kind of chewing away at this in segments so that I don't push it like too far out and actually deform the plastic around it too much. So this is going to be quite ugly, but quite functional, and it'll be on the inside of the device, so whatever. If it's ugly, it's ugly. It's only ugly on the inside. Oh yeah, I am making a disgusting mess of this. Alright, let's see. You can watch me make a disgusting mess of it, perhaps better from this angle. And, you know, not necessarily the best use of these snips either, but I got like 4 of these hanging around, I think. So, you know, if I ruin one pair, they're not expensive. These were, well, I don't even know how much they were. They're like $5 or $6 on Amazon. Everything I buy is from either Amazon or eBay. Getting this flush is going to be the tricky part, because all these are flush cutters. I have to be able to get the handles low enough into this, and my hands. I think that's successful though. It's not 100% flush, but if I don't cut it completely flush, the LED is going to be at an angle. At least flush enough where the nut needs to land on there. That's not a bad job. I mean, it almost looks intentional. Like I did that with some kind of precision tool. Almost. Oh, come on. This isn't even necessary because the nut that holds us on isn't going to go that far. There, and now we should be able to get that component in there. And then if I could pick up the nut. Yeah, that'll spin on there nicely. And I didn't tighten it down yet, but there you can see it'll all work out well enough. Well enough is the name of the game. And then likewise for the LED. Oh my god. You know what I just did? See, I was just talking about hubris with this. This is exactly what I was just talking about. For fuck's sake. I wasn't paying attention, and I was thinking about the holes for the banana posts, right? To drill almost all the way down to the bottom of the step bit, and I just went apeshit on that hole and cut it way too deep, way too deep, and therefore way too wide. That's how it should be. That's how it is. Fuck. And that is way too wide because I'm pretty confident I know what's going to happen when I try to put this in here. It's just going to fall right through. So what's the solution there? Well, there is no great solution because, first of all, this is going to be there, so I can't necessarily use a bigger indicator light because its surround might butt up against that. So what I'm probably going to do, which is going to be a very ugly fix, is put a washer, like just a regular metal washer underneath this, if I could find one that's sized nicely, that's, you know, the inner diameter can accommodate this, but not so big that I can slip through, and when the outer diameter is bigger than this hole. And what I do is I put that one there, and then I also put a washer under this one, even though it's not necessary, just so that they look symmetrical. And then that is going to have to be what happens. And obviously a washer on the underside too, to hold the nut under there. Fuck. Well, that was quite dumb. And you know what? With that, it's almost 3 in the morning. It is 2:53 where I am. I got 2 more holes to drill, but besides the fact that I'm tired, that has thrown off my confidence. I have a feeling if I try to drill those 2, I'll just go right through the whole fucking box through the bottom of the table. So I'm going to call it quits while I'm still somewhat ahead, and pick this up tomorrow or the next day. Because tomorrow's work day and I have to be up at 9, or slightly before 9. Because it's virus times and I work from home now, so I just have to roll over and log onto my computer. So, you know, 8:57. But still, it being 3 in the morning, I'll watch a little TV, I probably won't fall asleep till 4. Whatever. Anyway, have a good night, a good morning, whenever you're watching this, because no one is watching this live. But if you watch the whole recording to this point, well, thank you. Good job. And have a good day, night, whatever. Bye. Let's just go with color bars. Yeah. This way I can actually go on here and stop the streams. I know you can still hear me, that's fine. I will end the YouTube stream first, just for funsies. And I will end the Twitch stream second.